Hi, everyone. So my name is Lucy Collins, and this is my coworker, Binita Mehta. And today we're going to talk to you about CQRS and content management at Gannett, which is the headquarters for Gannett is right across the highway. So a little bit about us. I'm a product manager at Gannett, and I've been there for about a year and a half. Binita has also been there about the same amount of time, but she's one of our amazing developers. And we are part of the Gannett's content engineering team, which manages the Presto content management product. The content engineering team has been building this product for about 3 to 4 years. So Binita and I are relative newcomers, so I definitely want to give a big shout out to all the people who have done so much amazing work on this product. So now for a tiny bit of background. So Gannett owns USA Today and a bunch of other local media organizations across 34 states, so over 100. A couple of these organizations are the Detroit Free Press, the Arizona Republic, the Indy Star, and the Tennessean, to name a few. Do any of these papers sound familiar to anyone? Anybody read the Detroit Free Press? Okay, cool. So we have about over 2,000 journalists working across these newsrooms, so they're reporting on everything national to local news. Gannett did win 3 Pulitzer Prizes last year, so we like to tout that whenever we can. Explanatory journalism, local reporting, and editorial writing. Definitely see me after because there's some really great content in there. And we typically rank in the top 5 organizations for news and information, and we reach about 50% of the US digital population. So now that we're all introduced, you know Binita, you know me, you know Gannett, this is what we're going to talk to you about today. I'm going to give you a demo of the product and the use cases that we serve, and Binita is going to run you through the architecture and the technical details. That'll be the bulk of the presentation. Keep your ears peeled, because at the end, we're going to be asking some trivia questions about the presentation, and we have swag if you have the correct answers. So everybody loves swag. And then we'll have a dedicated Q&A session at the end, but if you do have a burning question, raise your hand, let us know. Okay, so Presto is the tool we've built to make it easy for journalists to create, discover, and publish content quickly. That's like the fundamental core business proposition of Presto. But it's also really important that our reporters can build robust visual multimedia stories. Storytelling these days is all about the images, the videos, the galleries, the audio enhancement to build a cross-functional story. And then the final thing we need to do is allow our users to collaborate with each other easily. So we have reporters across 34 states, and they have skills that supplement each other, and it's essential that they can work together easily and in real time. So that's another key factor for Presto. So ultimately, the overarching mission of Presto is to enable newsrooms to focus on content creation without getting bogged down in content management. So in the past, for all of our newsrooms, content management looked like lots and lots of shared folders, long lists of images and videos that were kept in vastly different places. It meant passing around Word docs and Google Docs and trying to maintain good versioning and good history there. It meant posting your story in multiple places with multiple workflows. So trying to get your story onto the web, the mobile apps, Facebook, Apple News, Twitter, all of these were different workflows that just took up valuable reporting time. So now our users can do all of their own creating, editing, collaborating, and enhancing in one place, Presto. So journalists use Presto to write many different kinds of stories. The one you're probably most familiar with is breaking news. So last month in Missouri, there were really bad tornadoes, and the Springfield News Leader, our team in Missouri, needed to cover this information for a local audience, giving them information on power outages and announcements from the governor, that kind of thing. But USA Today was covering it at a national level, letting you and me know what was happening at a higher level. Another use case to talk about are long-term investigations. These are stories that evolve over years and months, multiple people across multiple states collaborating to build out stories. An example of this is our recent deadly deliveries story, which talks about how the USA is the most dangerous development to give birth in. So it's a really important story that needs time to develop and be crafted. But the most common use case is just regular day-to-day beat reporting. So a reporter has their regular content that they create within their area of expertise on a day-to-day rhythm, and they publish stories every day. So we're going to walk through that use case in a lot of detail. So let's cast our minds way back to when I was writing this presentation in May of 2019. Winter had come and gone, but Game of Thrones fans were still very much in the thick of it. They were anticipating, maybe dreading the final episode, and many fans had been unhappy about recent changes or the recent storytelling with Game of Thrones. And a USA Today entertainment reporter heard about a growing petition for a rewrite of Game of Thrones Season 8. I don't know how many Game of Thrones fans we have in the room, but did anyone happen to sign that petition? Yeah. All right. So our reporter goes into Presto to tell this story, to do his job. And this is what that looks like. So here's a recorded demo of Presto. You can see on the left all of the different content types we allow our reporters to create. So stories, storylines, images, galleries, etc. But we're going to focus on the story creation flow today. So he clicks on the Create Story button. With a quick name and a category for the story, he's ready to start writing. He'll add the main headline, and he'll use the text editor to write the story. So it's a very basic text editor with all your kind of standard tools there. He'll also start adding in, at this point, this is a more complete version of the story. He'll start adding in the essential metadata that's important for SEO, that's important for how the content displays on our sites. You'll also notice down here that these content tags were added automatically based on what's written in the story body, but he can manually add content tags too to connect it to other pieces of content. When he's done writing, he'll start adding in video and image collection, we call them galleries, into the story body to enhance the story. These assets were actually created to accompany all of the Game of Thrones stories, or most of the Game of Thrones stories published during this time period. So reusing and recycling that content is extremely efficient for our newsrooms and allows them to create a visually stimulating story without getting, having to create multiple pieces of content. When he's done, he clicks the publish button. And within seconds, it's on the web, and it's on the mobile apps, it's discoverable in Google, and with a few more clicks, he can send alerts to all of our subscribers, et cetera, to disseminate that story fully. So that is the basic Presto workflow. I know you guys are here to talk with Binita about the architecture, but before we jump into that, do you guys have any questions on what we just saw? Yes? Oh, yeah. I did jump over that. I know I mentioned collaboration was really important at the beginning. We do have multiple collaborative editing tools. So if he sends it to his editor can make changes at the same time that he makes them and continue to build that out.
Editing, where to lock certain assets, concurrent edit, or we do that concurrent edit, but we make sure all the changes are synced in correctly. So all that. So the system itself has a lot more features than we're going to show today, but that would take up an entire day.
Yeah. Anybody else? Okay. Do you have a microphone?
All right. Thank you, Lucy. And thank you, everyone, for being here. Everyone still awake? Awesome. So I'll be going over.
Just enter.
Yeah. I'll be going over the Presto system or our authoring stack from an architectural perspective. But before I do that, I wanted to give a quick shout out to the content engineering team at Gannett. And I see some familiar faces here. Okay. Because a lot of work was in play before we even joined. So 3 cheers for content engineering. So the different architectural patterns that we're going to go over today are these. First one, EventDriven Microservices, which talks about basically splitting up a big application into a collection of loosely coupled services that communicate using events. Second, CQRS, stands for Command Query Responsibility Segregation, which is all about separating out the models for reading and writing information. Third, event sourcing, where changes to application state are stored as a sequence of events as opposed to just storing the current state of the application. Fourth, domain-driven design, that sort of brings some of these patterns together and helps divide large models into bounded contexts and also helps define an ubiquitous language across different parties. So with a show of hands, how many of you have heard about or worked with at least some of these patterns? Okay, awesome. So for those of you who have not, you can obviously Google any of these patterns and read what they're all about. Today, we are also going to talk about how these patterns have helped us at Gannett, why we decided to choose them, and the lessons learned along the way. So a quick look at our software stack. The Presto demo that Lucy showed, it's all AngularJS, so that's the front end. We have Node.js microservices in the backend, and Presto backend is also all Node.js. We use Couchbase as our data store, Solr for indexing, Google PubSub for our queuing infrastructure, and RabbitMQ as well for queuing. So let's talk about the first pattern we talked about here, right? Event-driven microservices, which is basically splitting up your application into a collection of loosely coupled services that communicate using events. So why did we pick this, right? Why did we decide to choose this at Gannett? Here's why. First one, scaling. We wanted to be able to scale different pieces of our application differently. So I'll demo the different microservices shortly, but we have a microservice called the index handler that does indexing of every single asset of ours with every single update, pretty much. So you can imagine the amount of resources that would require, as opposed to something like an image handler, which is yet another microservice that deals with just images and requests crops for these images from Google Vision. So scaling these separately was very important to us. Secondly, we also wanted to reduce the risk of doing big deployments at any given time. So it's nice to be able to deploy little microservices one at a time. So just the other day, we had a production issue where we had issue publishing image galleries. So of course, publish handler, which is a microservice, was at fault. We fixed the issue, figured it out, but it was nice to be able to just deploy that publish handler separately as opposed to deploying the entire architecture. So that reduces a lot of risk for us. Technical challenges. Thank you. All right, so let's look at what event-driven microservices look like for us at Gannett. This is a simplified picture. In reality, it's a lot more complex. So that's the Presto CMS that Lucy demoed, the green box. That's our user interacting with Presto CMS. And I'll let Madam Product Manager here, our awesome product manager, dictate what the user flow is going to be like. So Lucy, what should we have the user do first?
First step is always to create a story.
All right. So that's our user interacting with Presto, hitting the button to create the story. That, in turn, emits events out to our queuing infrastructure, and it also emits an event out into our data store for storage. The event that's emitted out onto queuing is now picked out by two of our microservices. So the boxes in blue that you'll see are our microservices. Here you see two. One is the index handler. The other is the snapshot handler. These two consume the event from the queuing infrastructure. And the index handler then stores that event into the indexer, so we can read it out or discover it later. And then the snapshot handler stores the snapshot of that asset or of that piece of content into our data store. And we'll go into a snapshot handler a little bit more later. So this flow that you see right here is going to stay on the screen because all this happens in the background for all subsequent flows. So Lucy, once the story is created, what's next?
It's time to add an image to this story.
All right, let's talk about adding an image. So what happens when the user comes in? We saw the lovely Game of Thrones story, but what's that story without images, right? So that's our user interacting with Presto, trying to add images. That in turn, once again, emits an event out onto the queuing infrastructure, which is now picked up by our yet another microservice, the image handler, for what? In order to request crops. It talks to Google Vision API to request crops. In turn, communicates back to queuing, and queuing lets the user know that these crops are now ready. Lucy, you want to talk about the crops a little bit?
Yeah, crops are really important for every kind of image event that we have. In the past, every time a user uploaded an image, they would have to select 5 different crops for that image manually. But through Google Vision's cropping service, all of that can happen automatically, and it saves a ton of time for our end users in their workflow. And the image displays well across all of our different presentation endpoints.
Yes.
So difference between the constant querying with the data store where it's created and the thing that is getting written when the snapshot happens. What's the difference between these two? Isn't it the same concept? The data store?
So the data store stores the snapshot of the story, let's say. And what was your other question? Which other piece of?
So
Yeah,
all of the events, sorry, go ahead.
no. So I'll talk about this. So Presto CMS that stores events into the data source data store is for the purposes of event sourcing. So that is to build out the aggregate later on. But the events that are emitted on the queuing infrastructure are essentially for all the microservices to pick up and deal with it. So there are 2 different types of events. Okay, Lucy, now that the images are added, what should we do?
It's time to add a video.
Yes, in this world of digital storytelling, videos are obviously important. So let's add a video. That's our user interacting with Presto again, emitting an event to the queuing infrastructure. That in turn gets picked up by yet another microservice of ours, the video handler. That in turn communicates to the transcoding APIs. And that in turn, in an asynchronous fashion, talks back to our video APIs, back to queuing, and back to the user.
And the transcoding API generates multiple renditions for videos, again, so it displays correctly across every presentation endpoint we have for the story, every different format. And the user has to do nothing in Presto. That all happens automatically, so it's another big time saver.
Awesome. So what you saw here, the boxes in blue are 6 microservices of ours. So that's a very simplified diagram. In reality, we have more than double that number. So before I move on to the next one, what's left for the story, Lucy?
As always, it's time to publish the story.
All right, so let's publish the story. That's the final step to make the story available on the web. That's our user interacting with Presto. Presto talking to queuing. Queuing in turn emits an event out to our publish handler. The publish handler in turn now sends the story across to our presentation ecosystem. This presentation ecosystem is basically a stack of yet another set of microservices with its own data store, its own indexer. We're not going to get into a lot of details there today, but keep in mind that's where the end user on the web or mobile would consume the story from. So once that's sent out to presentation, the publish handler then communicates it back to queuing, and we let the user know that the story is published. Any questions before I move on to the next one? Yes. Socket.io. It's asynchronous.
Local development for all this.
Yes. So on local, we don't use containers, but everywhere we can use containers. We generally don't, but all other environments are containerized. Sorry, you had a question? So we don't have an homegrown system for that, but the content tags that Lucy mentioned to add the stories, that's sort of like machine learning when it learns what content tags to add to what content. And we're only scratching the tip of the iceberg there. There's a lot more we can do that's in our product pipeline, but for now, that's what we're doing. Okay, let's move on to our next one, which is CQRS, which is also the title of the talk, so probably the most important here. CQRS stands for Command Query Responsibility Segregation, and basically talks about separating out the models for reading and writing information. So why did we choose to go with this, right? Why was this important at Gannett? So A, scaling. Because the read and write models are separated out, we can now scale reads and writes separately. With a show of hands, anybody, why is that important? No? Okay. Most systems generally have a lot more reads than writes. So it makes sense to separate these two out so they can be scaled individually.
So,
Also,
for example, at Gannett, if you have 1,000 people reading a story, that requires a lot more power than 1 or 2 people working on a story in Presto CMS.
and this also helps with availability, right? So for example, how many of you have had issues with production systems going down? So imagine if the right side were to go down, read side still stays available, and that's very important to us.
Mm-hmm. So if Presto goes down, it has in the past, we've gotten a little bit better at it lately, but it has definitely gone down. It's essential that our end users can still read all of our stories and go to the USA Today and find content.
Okay, so let's take a quick look at what that looks like for us. That's our user again, interacting with Presto CMS, hitting the button to create a story. That Presto CMS in turn sends out a command, create story, to our command model. So that command that you see is the C in CQRS. That in turn writes out an event, story created, into the data store. Similar flow happens for publishing a story. The user is now hitting the button to publish the story, sends the command out, publish story, into the command model. That in turn writes out an event, story published, into the data store. So that's the command piece of it. Now let's look at what the query piece of it looks like. So let's say a user comes in, requests to view the story. That in turn gets read out from our read data store into the query model and gets presented to the user. So that query read story is the queue in CQRS. But wait, there's more, right? So we talked about the presentation ecosystem a little bit. So this data store, this authoring data store in blue, also communicates to our presentation data store via event buses, so we can separate out the reads from the writes. So if a user were to come in from the web and request a story, that gets read out in a similar way via the query model and gets presented to the user. Similarly, on the mobile devices, query read story gets presented out to the user. Before I move on, any questions here?
In your query options there, is there a small request going from the client side back to tell that it's still some communication? Or, because in the picture you have, it looks like the data store is preemptively sending the information to the user.
No, it happens once when the information is requested, not preemptive. All right, so the next pattern we are going to talk about is event sourcing. So event sourcing is basically where changes to application state are stored as a sequence of events. So we don't store just the current state. We store it as a sequence of events. So why is that important, right? Why was that important to us at Gannett, and why did we pick this pattern? So what that sequence of events helps us do is preserve history. So for any piece of content within Presto, we can go back in time, right from the time it was created, to see what changes happened to that particular story. So the other day, I was looking at an issue where someone was like, hey, I published this story. It was available for a day. Then it disappeared for an hour. It was available again, right? Where do you start? If you were to only store the current state of the application, would you be able to tell what happened to the story? No, but in this case, we could go in, look at all the events for that story, and what we realized that for the time that it had become unavailable, someone had actually unpublished the story. So there was an unpublished event in our data store, after which it was republished again, and hence it became available again. So capturing all those events for a particular piece of content is very important. Also, that lets us do time travel. So for example, if an editor came in and said, hey, something was off with my story earlier, it's fine now, but it was off earlier, right? How many times have you heard this? But it works for me now, right? So in that case, we can go back and recreate the story at that point in time and look at what was off with it.
And this is also really important for our editors and our reporters in the newsroom too. They have access to a version history tool that allows them to go back and see what it looked like 10 hours ago when they were writing on it then, and go back to that previous version if they need to, which is pretty essential.
And what this also helps us do is, because our data store basically is a bunch of events. It's all the events related to an aggregator. It also helps us rapidly evolve. So tomorrow, if we wanted to add a story, or if we wanted to now add images, if we wanted to add video playlists, everything is basically stored as a sequence of events. We don't have to go out creating new tables. We don't have to go out creating new columns in the database if we wanted to add new properties to the object, so on and so forth.
And that's, I mean, it's been very important recently as we've built up the tool from the beginning, and we've added images, videos, galleries, promos, storylines, video playlists, all in the past year and a half. But as journalism continues to evolve, and we need to include VR content, we need to include more and more audio, like we can rapidly grow our product to serve those needs.
All right, so now let's look at what happens when someone comes in to Presto and requests a story, right? How do we build a story out from all these events that are stored in our data store? So that's an empty story. Let's say we first read this event story created from the data store, gets applied to an empty object, and now produces a partially hydrated story with the ID, who created it, and the created date. So that's our Game of Thrones story, created by Jamie Dearvester on 16th May 2019. Next, we encounter the story headline set event from the data store. We apply it onto that object, and now we have some more data in the story, which is now the headline of the story. Similarly, you'll see a story body set event comes in. Gets applied to the story. Now we have the body of the story. On the bottom left, you'll see, on the top right, you'll see an image gallery was added. And now you see the Game of Thrones image gallery in the story. We add the video added event comes in. And now we have a story, almost complete story, with all the assets added onto it. Last but not least, we have the story published event that comes in, and now we have a fully published story, saying who it was published by and when. So before I move on to our next pattern, any questions here? Yes. We use Couchbase.
In your Presto, I think you mentioned promotion when you were talking about earlier. Does it plug into, because the end goal of all of this for the enterprise businesses to make money, how does that plug into your financial model?
So the side of the business we're on is focused on kind of making journalists more effective and efficient. We definitely have teams who are ad rev and different teams focused on building out the money-making sides of the business, but this is really focused on efficiency and streamlining content creation in that process. Yeah.
And to add to that a little bit more, so for example, on our side, when we create a story, we assign classification to that story. And once the presentation side sees what classification is assigned to that story, they can decide what advertisement they want to place into the story.
Denise? Yeah.
Yes.
So usually the user can talk to something
Not yet. We're working on that because it's definitely a big need that they have. If you have, even while you're working on something, if it's a top secret story, you don't want everybody across the network to be able to see it, or if it's been published, you don't want anybody to be able to touch it or change it. So those are tools we're going to continue to build on.
But to add to that, we also have locking from a concurrent editing perspective. So if two of us are editing stories at the same time, if I'm in the body of a story, nobody else can be the body of the story, vice versa.
We have high-level permissions, so people can, restrict story editing for this site and that kind of thing. But it's definitely groups of users have access to different things.
Okay, so let's talk about domain-driven design. Domain-driven design basically divides large models into bounded context. So, too much jargon there. Why is this important, right? What helps us do is define an ubiquitous language across all the parties involved. So by all the parties, I mean developers, product, newsrooms, any other business people involved. And Lucy can tell us how the newsroom refers to content, right?
Yeah, so you might have, in my demo, heard the language that we use, right? So instead of calling an article, we call it a story. And that comes directly from the newsroom, and that's kind of, it trickles down to the whole, all of our systems. We call a collection of images, we don't call it an album or a collection of images, we call it an image gallery. And that kind of thing is intrinsic to the product.
So instead of our developers using CRUD, and some of you here may be familiar with that, it stands for create, read, update, delete, and just talking about creating a story, updating a story, creating an image, deleting a story. We now have clear language in place, create story, add headline, set body, add image gallery, so on and so forth.
Oh, sorry, just go down to the bottom corner. I have those smart corners turned on.
Again,
They're not very smart.
I did it again. Okay. And what it also helps us do is define boundaries. So what do we store events for, right? Like, do we store events for everything that happens across our entire application? No, that would be too much. So we try and segregate, and different teams define this differently, even across the industry. But like how we define boundaries is we have boundaries for our stories, for our image galleries, or the basic assets that we have. And then we also have boundaries for like something external, like we do, like for example, the content tags that Lucy showed, that's a whole different system for us. And we don't store events for that particular system. We just treat it as an external system and communicate with it using our public-facing APIs. So, you want to talk a little bit more about that?
Are we running out of time? Now are we stuck? Okay.
So let's talk about domain-driven design. Okay, there, something happened.
Let's just jump back in. See?
So let's see what the domain-driven design looks like for us. The diagram that I'm going to show you in that world is known as the context map. And that's our broad authoring domain. Within the authoring domain, we have the story subdomain. That's the story piece that Lucy showed. We also have the image gallery and the video subdomains. The story, of course, interacts with these two, but that's not all. This external domain is the one I talked about earlier. That's the domain that deals with adding content tags to the story. So editors can search for it later, and the story of our authoring domain or the story subdomain interacts with this external domain using public-facing APIs. And the boundaries you see here, that those are the boundaries that I was talking about that help us define what we store events for and so on and so forth, are known as the bounded contexts. So to talk a little bit more about domain-driven design, these are some of the concepts of domain-driven design. Ubiquitous language, we already talked about that. It helps define a common language across all the parties involved. The second most important one is the domain entity, which is implemented using an aggregate root. So a domain entity is basically something with characteristics. So in simple terms, think of it as a class. And that's implemented for us in a way. Look, you can see the story aggregate root there. So what you see there is it's basically something that it's like a root level object that holds references to everything else. So in this case, in the constructor, you'll see that it's holding a reference to the domain model. And then it also has all the behaviors or the commands, the CQRS commands associated with it. So it's got, for the story, it's got the create, set headline, set body, add associated assets, so on. So let's look at the domain model, right? What is domain model? Domain model is basically initial state and then event handlers that create that state as the events are played along. So for us in the story domain model, you'll see the initial state in the constructor. And then as the events come in, the object gets hydrated. So in this case, we have the created, headline set, body set, so on. And then behavior drives state. What do I mean by that, right? So for every command in the story aggregate root, you will notice at least one corresponding event in the domain model. So for the create, you have created. For the set headline, you have the headline set, so on and so forth. All right, so before I move on, any questions here? Okay. So to give you guys a quick recap of all the advantages that we talked about. rapid evolution, time travel, scalability, availability, and isolated deployments. But that's not all, right? Not everything is rosy. There's always challenges. So let's talk about some of the challenges that we have seen in our journey at Connect. Performance, right? That's number one. Because everything is stored as a sequence of events, it's fine for most aggregates that have a few hundred events, but some of our long-running assets, like for example, the USA Today Homefront, which is nothing but usatoday.com, has accumulated over 15,000 events in the course of its lifetime. So if we were to build this out every single time someone requests it, that would be super performance intensive. So that's where the snapshots come in. So anytime we get any kind of events for an aggregate, we store its snapshot in the database. So future requests, we just present it from the snapshot. Also, not all views need all kinds of data, right? So for example, if you were to present stories within the search result, it only needs headline and maybe a couple other fields. Whereas if an editor is editing the story, it needs everything. So that's why we have projections, also known as read models, akin to views in the SQL world. So eventual consistency, right? What is this? Because in CQRS, the reads and writes are separated out, the data models are separated out, there's a little bit of a delay before the reads catch up with the write. And we are okay with it. To understand why, let's look at the CAP theorem. So the CAP theorem, CAP, stands for consistency, availability, and partition tolerance. And what it states is, in case of a distributed data store, and in this day and age, distributed is very important, you can only have 2 of these 3 things guaranteed. You cannot have all 3 things guaranteed, which is not to say you cannot have all 3 most of the time, but only 2 of the 3 are guaranteed. So in our case, we have chosen to be, chosen to guarantee availability and partition tolerance, with the challenge being that we're eventually consistent. But in most cases, the delay is only a few microseconds. To understand the CAP theorem a little bit better, let's look at the HHC theorem. Has anybody heard of it? I think the parents here in this room will appreciate it. So we have, the HHC talks about happy kids, happy parents, and clean house. And you can only have 2 of these 3 things guaranteed at any given time. So in my case, I've chosen happy kids and happy parents. And now you know why my house is always messy. Let's talk about the next challenge, paradigm shift. So it's a different way of thinking, right? Storing everything in a sequence of events, reads are different from writes, so on and so forth. It takes some time getting used to. Like if someone new comes on board, it takes some time for them to get onboarded. When I joined, it took me a couple of months to actually understand end-to-end how everything was set up. And then last but not least, debugging. I think this, in general, comes with microservices architecture, because everything is split up. If something goes wrong, where do you start, right? So in order to overcome that, what we have log aggregators that aggregate logs from all our microservices, and then we can look into everything as a holistic picture. But in general, that can still remain a challenge. So these are the references I have. If you're interested in any of these patterns, I highly recommend them. Very, very good. And now for some fun stuff. We have trivia questions. I hope you guys were paying attention. Lucy, you want to go first?
For all you Game of Thrones fans out there, throw back to the beginning of the presentation. What is the name of Jon Snow's direwolf? Raise your hand. Yes. Benita, are they in the bags?
Yes. No, they're not.
Sorry, I know we give us an easy one.
Swag.
We'll look over here next time.
All right, while she gets the swag sorted, I'll go on to the next one. Okay, so that was right. What does CQRS stand for? All right, I saw that hand go up first.
Clearly responsibility segregation.
Nice.
Awesome.
Segregation. Multiple swags. Mm-hmm. I got you. You can keep going.
All right, Lucy, you want to go next?
How many Pulitzer Prizes did Gannett win last year? Anybody remember?
That's a tough one. You get a Bluetooth speaker for this one. All right, I saw that. Awesome.
Yeah, who said that? It wasn't a niece, right? Yeah.
All right,
Who was it? Was it you?
last one. Which architectural pattern helps us with time travel?
You'll never know.
No, sorry. Yes. Sorry? Yes. Person in the back for events or something.
It was you, right? Awesome. I don't know. Get the Bluetooth speaker. We give out multiple sway.
All right, so we are here. Now we know that it's lunchtime. I don't know what time is it exactly, but if you guys want to head out to lunch, feel free. We'll be here for any Q&A.